Good morning, Vananda. The subject name is compiler design. In the previous videos, we discussed about the types of parsing and top-down parsing approach as well as bottom-up parsing approach. Now, in this class, this session, we are going to discuss about the concept of predictive parsing. Here, the predictive parser takes place several steps. So here the learning outcome is parsing, a concept of parsing types as well as predictive parser. And then the derivation trees while applying these parse trees for bottom up in case of top down and bottom up parsing techniques. Let us look into the glance of this tree. That is a parse tree mechanism. In the previous video also we have taken this hierarchical notation where categorized into top-down parsing, bottom-up parsing, where it is divided into top-down parsing with full byte tracking and top-down parsing without backtracking. Once again, this top-down parsing without backtracking, there will be two types. It is a recursive descent parsing without backtracking, and another type is non-recursive descent parsing without backtracking. This is also called as LL1 grammar. So this where predictive parsing comes. And another category, that is the right side, we are going to see shift reduce parsers. These are called as a bottom-up parser. Previous videos we discussed about how the top-down approach can be implemented and bottom-up approach implementation notations. In this category, it is divided into broadly two types. One is operator precision parser, second one is LR parser. Once again, these LR parsers are categorized into LR, simple LR, CLR, that means canonical LR, and finally LALR, that is called as look ahead LR. These are the different, these things we are going to see one by one for the coming classes, each of the description separately one by one. Now in this mainly we are going to concentrate on the concept of predictive parser mechanism. So in order to apply the predictive parser mechanism, first the foremost conditions that is to be satisfied for the given grammar, whether the grammar contains any unreachable productions or not, that is to be verified clearly at the grammar notation, whether it is reachable or not. So in this case, the grammar, we can say that it is not reachable. Then that type of productions can be identified and then that is to be removed from the grammar. That means the grammar is free from unreachability of the production. That means what happens if unreachability arises, then there is it is very difficult to the compiler to get the solution for that parsing mechanism. In order to generate, previously you have seen the mechanism of predictive parsing where input and stack contents and then parse table is generated, then output based on that. So here in this case, in order to generate that output notation, we are getting the difficulty arises if the grammar is not free from the reachability of the production. So that's where here the plays important role. First, second one is ambiguity. So ambiguity arises whenever the grammar contains more than one leftmost derivations or rightmost derivation trees. That is this part also we have taken the separate lecture in the previous videos. If at all the requirement, you can see that concept where the left and same derivation tree that is to be satisfied for that product grammar two of more than one then compiler is difficult to understand or verify the tracking of this, which of the parse tree to be considered for the compilation, not to go for the next phase of the compilation. So that is to be avoided. Another one is left recursion. Very shortly we will see the left recursion also, and the each one by one. And another one is left factoring. Left factoring also syntax we are going to verify one by one. And then we have to compute first and follow. First is one computation, another is one follow is one computation. This first computation is to be carried out for each of the symbols in the given grammar. Similarly, follow also another computation we have to compute for the given grammar to place some of the entries in the parse table. That is the table that is. So that is the final step, parse table. So these entries are to be placed. What are the entries that is to be placed? That computation. What are the computations first and follow? And what is the grammar? That is should be free from left factoring, left recursion, unreachability, and ambiguity. So these four are not available. That means they are free. That means there is no left recursion, there is no left factoring, and there is no ambiguity, there is no unreachability. Then we can say that the grammar is a suitable grammar which is for the construction of the parse table. So that free of these things available for the given grammar can be able to find the computation such as first and follow computation. Based on the first and follow computation, we are going to get some symbols which are satisfied for that particular entry into the table. So that entry to be written inside the parse table. Based on this entries, it can basically this parse table contains a row and column mechanism where rows contains the non-terminal symbols that are available in the given defined grammar, whereas the columns defines the terminals which are to be defined in that one, where the combination of this terminal and non-terminal values can be defined by the computations of this first and follow. These two are most important, and based on this we are going to get the results in these entries. These entries are to be verified based on that, and then we can say that whether the given grammar satisfies the predictive parser or not can be judged or verified. That is to be agenda of this today's class notation. Today's the concept which we are going to learn the basic things about the predictive parsing mechanism, where the rules are to be satisfied. First most and important rule, unreachability of the production. So here some of the productions example, some I have considered with one example. In this example, S derives A, and X derives N, G derives capital A, capital G derives capital A derives small e, capital J derives small m, capital D derives small d, capital U derives capital G. So in this list of rules, what are the things which are not reachable? We have to find out from the given grammar what is the unreachability of the production. So we are going to removal of unreachable production. So how to identify this unreachability of the productions in the given. So first we have to take the first and startmost entry of that is production, that is first one, that is called at the start of the root node, that is S derives small a. So this is to be considered. Why? Because it consists of the starting of the parse tree node, where the entry of the symbol table root node is available in that one. So here definitely the first and foremost production, the given grammar must and should be considered. So that is not at all removed from that one. So that is a first important one. So that's why we took this one, that is it is called as the root of this parse tree. So S derives small a, U capital A, capital U capital A. And then the next derivation, if you see X derives N, So this is not considered. Capital X derives small n is not considered. It is we are saying that it is removed and it is not reachable production. Why? Because this entry capital X and capital X, which does not depend upon any of the entry in the table. That means while evaluating this S derives small a, capital U, capital A, there is no evaluations depends upon the cases of the right hand side of the terminal. So we look into the case where the it's depends of the terminal which are available on the right hand side of the production. So if it is the case observe, it is small a and capital U and capital A, and you can see the remaining productions are also here G A, and third one, fourth one capital A E, J capital J M, small m, capital D, small d, capital U G. So here in all the remaining cases also there is nowhere of the non-terminal X defined on the right hand side of the production value. So there is no attachment or there is no evaluation of the substitutions or takes place for the remaining or all the remaining of for this which is to be evaluated with the remaining any other. So we are going to verify it. So in that case it is not at all satisfied. So that's why this is to be unreachable production. And capital G is derives, it is holds good. Why? Because here capital G derives A. That means the production capital that is here capital G derives capital U derives capital G and capital G derives A. So this first production we can use this one. So that's why capital A, which is available on the right hand side of the starting of the production, that is S derives small a capital U, capital S derives small a capital U capital A. So there is a non-terminal which is available on the right hand side. And also one more production that is available, capital U derives D. So where the production stands for. So there is an attached symbol which is available for this. So there is no removal of that one where the dependency occurs. So we have to verify whether any reachability is there. So here there is a possibility of a reachable condition. So that's why we have not removal from this remove this production from this grammar. So that's why we can keep it as it is. And the capital A derives small e also we are going to keep as it is. Why? Because here S derives small a, capital U, capital A, and capital A derives E. So there is a dependency where the left hand side of the non-terminal where it arises this capital A on the first start most of the production where capital A derives. So we are going to get this the substitution as capital A derives A. There is a chance of definitely dependency occurs the right hand side. Another one is J derives M. So here J derives M, if you consider this is not at all reachable because capital J derives small m. So if you observe any of the remaining productions, so here S for remaining production, S derives small a, capital U, capital A. There is no reachability in this one, and we have removed X derives N, and we have taken this G derives capital A. Here also there is no reachability, and capital A derives small a. Here also there is no reachability, and the remaining T derives D. This is also there is no reachability, and capital U derives G. So in all the cases, this production where the right hand side of the non-terminal where exists can be evaluated or substituted for the derivations or reachability occurs, then only we can consider it one. Otherwise, it is not. Then we can say that it is not reachable, and the production is unreachable, not reachable or unreachable. This production is not reachable or unreachable production. So this type of productions can be identified and that can be eliminated from the grammar. Since if at all if this type of productions are used are present inside the grammar, then there is no use of that one for the coming past generations, and it can be kept idle only, and there is other scope of memory, time, executions, and these calculations are to be depend on, and that's why these to be verified and then to be eliminated from the given grammar. So such is the one of the important point for this first one. And if you see that T derives T, this is also same one, capital D derives small d, which is not at all to be considered. Why? Because it does not depend on any of the production. And where a capital U derives G, this one is to be considered. Why? Because capital G derives capital A, capital U derives small g. So this is there is a dependency arises in both the cases. So we considered a capital U with capital G. So that's why this is to be considered. So if you observe the given productions, so that's why you kept this 4. And what are the remaining cases? That is X, capital X, N derives N, and the second one is capital D derives small m, and the third one is capital T derives small d. So these three cases out of the given 7 rules, 3 rules are, these rules are not reachable. These rules are not reachable. Why? Because what are the entries that is to be defined, capital X and capital J and capital D, which are not used to be further definitions of the right hand side of the terminal, non-terminal cases for the remaining. So here if you observe, there is no capital X and there is no capital J and there is no capital T. So for evaluation purpose, here each of the cases derives small a, capital U, capital A, capital G derives capital A, capital A derives small e, capital U derives small g. So here there is nowhere X is to be defined, and there is nowhere Z is to be defined, and there is nowhere attachment with the T. So if at all, if any the case occurs where reachability of the operations for each of the cases, then we can identify, and we should not remove these type of the rules. If you remove any of the rules which are attached, then it defaults, that means it deviates the exact output of the program. So try to verify carefully whether any direct or indirect reachabilities are also applied. Then we have to be considered. This is one of the examples. There are variety of examples where reachability occurs in different forms. So that is to be carefully analyzed and then to be considered. So if at all, if any chance of missing, then there is a possibility of deviation of the output occurs. So that is the one of the first step that is to be considered. Not only this grammar, for any given grammar to execute the predictive parsing program, the first and foremost step is to be verified whether the given grammar is satisfying this unreachability of the productions, reachability of the productions or not. If at all, if it is any chances, then we are going to carefully observe, remove that, and then start out this with a list of productions which are unreachability of the, after removal of unreachability productions, we are getting this type of notation. And then second most important factor for the consideration of predictive parsing table is precedences, and this is associated. So this is to be depends on ambiguity. Why ambiguity? In the previous videos also we discussed about ambiguity, that is called as ambiguity arises when the parser has more than one parse tree. More than one parse tree. So while generating parse tree, there will be more than one. So that is to be careful. If more than one parse tree means either leftmost derivations or rightmost derivations. Thus there is a chance of getting more more than one, either leftmost or either rightmost. So in that cases, the parse trees are to be parse tree. That cases grammar contains ambiguity. So we have to avoid. So now to avoid that ambiguity, we take place the two factors to be considered. One is the most important one, that is the precedence, and second one is the associate. So every grammar is having some associate precedence and associativity is available. That is to be taken care of by applying the grammar notation. If at all, if the grammar has ambiguity, then compiler has the difficulty where this construction of the phase of the compilation process. So there is no method inbuilt which is to be detected and remove that one. So you have to apply the ambiguity while rewriting the whole grammar without ambiguity only. That means to remove this ambiguity, we are going to apply the techniques that as precedence, and another one is associativity. So first look into the category of precedence. So in this precedence, we know that there will be several operators such as arithmetic operators and several logical and relational operators where the precedency, which one is to be taken place from the next one. So here we are going to consider that one as in the case of productions where the production with the levels. So which is the level, where the level of the production that is to be available. That based on that we are going to decide the priority of the operator. That means the level, based on the level we are going to apply this priority of the production. Suppose if the production is at higher levels, then priority with what is the priority we applied is rest priority. Production where it is higher levels getting the less priority. When the production is lower levels, then the production gets the higher priority. That means the operator where the place higher notation, that means it is less, and lower notation get higher. So this is to be applied with respect to the grammar and remove this ambiguity, one of the case. And second case is associativity. See here associativity, if the same precedence operators available within the given grammar, then we have to consider the associative. For example, plus plus, minus minus. So the occurrence of the operators are the same. That means A plus B plus C. So like this, the operators may exist with the same precedence. Plus having the plus and the second most also plus, then which is to be evaluated and considered for the cases where the associativity takes place either left to right or right to left. Suppose based on the parentheses or evaluations depends. Then we suppose if we consider a left to right and associativity, then we have to imply this as a case of left recursion for the productions. And if we keep on applying this left recursion procedures, then there is a chance of growing the tree leftmost only, and that tree is called parse tree is grows left side, and the continuation of the leftmost part of the derivation will be increased, then automatically the associativity applied, but it goes to the left. Whereas in the case of second right to left case, where the associativity applied and then the parse tree that is to be implemented, and right recursion is applied in this case, and then the parse tree is to be generated with the help of, and there is a chance of growing right hand side of the right. Why? Because here the leftmost case where left recursion with leftmost derivations are to be substituted at the for each of the symbols of the given grammar. So in that case, automatically there is a chance of increasing the tree at the leftmost corner, left side of the left chance. That means left side of the parse tree grows automatically. Whereas in the second case, that is right recursion, right recursion, that is a parse, that is the rightmost derivation, where the substitutions takes place at the right hand side of the productions, and there where we can use this rightmost derivations of the parse tree, that is the rightmost of past, that is to be grows automatically on the right side of the past. Whereas in the case of left recursion, we can see the picture of the leftmost. See this we can see an example of left recursion as the second. That is our predictive parsing mechanism. Next most important one is this one only. That is left recursion is to be able. So this is the concept where left recursion, where how the suppose what is meant by a left recursion. So how can I identify this a rule given grammar whether it contains a left recursion or not. So in this there is a general syntax notation of the format. For example, here A derives A alpha. So A derives A alpha is the production. For this first some string alpha, in this case we are saying verify whether the left recursion is to be ordered. So if whenever any of in the given set of rules, any rule which contains of the form, that is the form such as A derives A alpha, where A is one non-terminal and which giving the immediate left of right hand side of first non-terminal. Right hand side of the first non-terminal is the same as non-terminal that is available on left hand side. So that type of patterns can be observed, and then we can verify that this grammar is free from left recursion or not. So for example, what happens if we do not cannot eliminate this left recursion? So there is a chance of going the condition with the infinite loop. That means the parser is keep on substituting the same production. That means, for example, A derives A alpha. So once again, what A contains A alpha. So A derives A alpha. Once again, A derives A alpha. So once again, what A contains, A derives A alpha. A derives A alpha. Once again, A derives A alpha. Once again, A derives. So here they keep on implementing A1, A2, A3, A4, A5, A6. A power 7, A power 8, like that keep on incrementing, and the gross tree, parse tree are two words at one side, either left hand side or right hand side if it is a left recursion and right recursion. So there is no point where the end of the end result can be identified. That means it goes indefinitely, gross parse tree construction that is indefinitely, and then the loop is continued, then we can say that this one is infinite. Like while loop, while true, where the condition satisfied, then it indefinitely the execution takes place. So we cannot come outside of that one. So in the similarly here, for example, if we consider S derives SCD, this is one given production, and this given grammar, say for example, A capital A derives capital small a small b, and capital A derives D. These are the three productions which are given in this example. So whether here eliminate the left recursion case. So in this case, where the first and startmost entry where S derives capital S, capital A, capital A, small d. So the substitution of S and substitution of A may takes place depends on the evaluations of the leftmost and rightmost cases. So here, if you consider the leftmost, where S which further contains the same derivation, that is S derives capital S, capital A, small d. Where capital A may grows either capital small a, small b. And then there is no chance of further evaluations. Why? Because terminal appears. But here, if you see in this left hand side of this, once again there is a chance of evaluation of this capital S. So we further down the level of the paucity, capital S, once again capital A, capital E. So this is to be continued until the capital S is to be substituted with the corresponding formation notation. But here there is no such derivation which stops the continuity of this one. So this can be indefinitely continuing. Indefinite loop will be exist in this case. So that's why here capital S, capital A, capital A. Once again this capital S, capital S. Once again capital S. Like this, it grows past is indefinitely. There is no termination. So that's type of, if there is a pastis type, there is a type of this type of pastis, then compiler is not able to get rid of these results, and it cannot detect automatically, and there is a failure of the compilation process at the particular phase. Then it cannot move to the next phase of the compilation process, and then the output also can't be generated. So there is a failure. So in this way, we have to find out the elimination of find out the grammar which is free from left recursion also. So that's why we have used the general format where A derives A alpha, which is to be general procedure to find out whether this one. So in this example, S derives capital S, capital A, small d. So we found out the derivation with capital S, right hand side of the first non-terminal, which is same as left hand side of the terminal, non-terminal. So both are class. Then there is a chance of, there is a left recursion exists. So we found, and then we have to help. So for this, a top-down parsing methods cannot handle this type of left recursive grammar. So we have to handle a separate transformations. So what are the transformations that is required for this one? For example, here this is the syntax to eliminate left recursion. Eliminate left recursion. For example, here we discussed about left recursion format. A derives A alpha, and another one, there may be another productions are also A alpha beta, which is same as A derives A alpha is one production, and the second rule is A derives beta. Second rule is A derives. These are the two rules which are to be combined into a single production, into a single rule. So we can write the productions with which contains the same left hand side of the non-terminal, which is same. Then we can combine the both the right hand parts of the production. So that's why A derives A alpha beta. So where the existence of the left recursion to be avoided by replacing with these two rules. So what is the rule? A derives beta A dash is the first production, and second production is A derives alpha A dash, and A dash derives epsilon. So these are the two cases which are to be replaced. So based on this, we substituted with this one. Then we are going to eliminate the left recursion. Eliminate left recursion by replacing this with this one. That means A derives capital A alpha, which contains left recursion, that is to be eliminated by eliminating this production with substituting these two which are to comes from this same production. So let us see with an example. So this is an example where the production are given is A derives the E plus capital E. Capital E derives capital E plus capital T, and one more production is also given, that is capital E derives first we have to verify in this given example. Capital E derives capital E plus T and T. So this is of the format which is same as this one. So that means capital A derive, this is capital A alpha. A alpha, here A, this one. So A derives A, which is a left recursion, and plus T, that is to be considered as alpha, and T, that is to be considered as beta. And that is to be considered as beta. So now we applied the first one. So this is the same as A alpha beta. Now we have to apply A derives beta A dash. What is beta here? Beta is capital T and A dash is A dash. That is the first rule. And second one which we applied, substitution is for replacing of the general format A derives alpha beta is where A dash derives alpha A dash. What is alpha here? Plus T. Alpha is plus T. And A dash and then epsilon. So the first and second, these two rules applied for the given syntax of the form, and then we are getting these two. That means these two are A derive beta A dash, alpha A dash. From this we are getting this result. That means, so here we can substitute what is A to get this result. What is A? What is A here? Capital T. And what is capital? What is here? T you applied. Beta A dash. What is A dash here? E dash. That is the first one. What is the second one? Second one is A dash. A dash means E dash and plus T alpha A dash. What is A dash? What is A? Capital E. Capital E dash and then epsilon. So simply we are going to apply the rules with the instead of the left recursion rule, simply we replace with the two more rules. We are getting the result. So that's why the first production which contains left recursion, that is replaced with the to rewrite the given productions. This is called as the production, the given grammar rewrite and eliminate left recursion with the help of the syntax of this production, and then we are getting two more production. That means instead of this E derives E plus T, which contains left recursion, direct left recursion. So here we will see what is the direct and direct. Sometimes the recursion exists indirectly also. Next we will see that indirect left recursion also, how it exists. We will take one example also. Now this is the direct means we can see, we can able to identify the two symbols appearance, existence, and we can immediately identify that yes, there is a existence of left recursion. Where sometimes we cannot identify directly, there may be indirect also. So that type of example also we can see. So in this case, you are able to see that directly the right hand side of the first most non-terminal, which is same as the left hand side of the non-terminal. Then there is left recursion exists. Then we have eliminated this case and replaced with the two more case. A derives T dash, and the second one is E dash derives cap plus T capital E dash and then epsilon. So these two makes release of this left recursion, and we have successfully executed this one. So what is the general formula of notation is A derives A alpha beta, A alpha and A derives beta, if at all, if the chance of the general format, then replace with the A derives beta A dash. This is the first production, and second production is A dash derives alpha A dash and epsilon. Here there are two productions. Alpha A dash is one production, another one is epsilon is another. So here in the given example, what is A? Here in the given example, A is capital E. So A is capital E, and beta is capital T, alpha is plus T. So we have verified this is capital A, and this is also capital A, and this is alpha, and this is beta. So where the replace with the A derives beta A dash. So capital E derives capital T E dash, and A dash derives alpha A dash. Alpha A dash means plus T, and capital E dash and the epsilon. So this is the general format for meter. So we are at the phase of the third point where the predictive parsing can be implemented with the help of this. So here the points to be considered for the implementation of predictive parsing is unreachability is to be removed. We have seen it unreachability first case with an help of example, and we have seen ambiguity in the previous videos also. If at all you see that one leftmost where the derivation exists more than one or the leftmost or rightmost, we are going to eliminate it. And then just now we have seen in left recursion implementation, direct recursion. So next class we will see that how the indirect left recursion are also exist with the help of that one. And next we will see the remaining parts in the next coming session. The remaining part where the left factoric and how the computation of first and follow. And then finally we are going to draw a parse table, and then that parse table we are going to keep that entries, what are the computations of first and follow, and then we are going to verify that this predictive parsing follows the corresponding grammar or not. So this is how the construction of predictive parsing takes place. So in this series of steps we have come into the concept of left recursion where the direct exists. Next class we will see that indirect left recursion with some examples, left factory, first and follow, and the parse table constructions. Thank you very much. Thank you one and all. Now we are going to stop the session. Next class will come with the remaining concept of the predictive parsing mechanism. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.